A database is a structured collection of data organized so it can be searched, sorted, and updated efficiently. The word structured is what separates it from a file. In topic 8.3, we wrote lines to a text file, and that works, but finding one particular record means reading through the whole file, and there is nothing preventing one line having 4 values and the next having 6. A database imposes a structure. Every record has the same fields, each field has a declared type, and the system can search on any of them without reading everything. That is the trade. You accept a fixed shape in return for reliable searching and validation. 3 terms, and they are simple provided you attach them to the right direction. A field is a single item of data, one property such as a surname or a price. In a table, a field is a column. A record is all the data about one thing, one student, one book, one product. In a table, a record is a row, and a table is the whole collection of records. So the way to keep them straight is the one the page gives. A field is a column, a record is a row. If a question asks how many records a table holds, count rows, how many fields, count columns. Getting those the wrong way round is a needless way to lose a mark on an otherwise correct answer. A primary key is a field that uniquely identifies each record in a table. Every record must have one. No 2 records may share the same value, and it cannot be left empty. And the reason it matters is that without it, 2 records could be completely indistinguishable, and the database would have no way to say which one you meant when you asked to update or delete a record. So the primary key is not merely a label, it is what makes an individual record addressable at all. That is also why it is the field a database indexes first, and why searching on the primary key is faster than searching on anything else. Choosing one is a judgment, and the table on the page works through the candidates for a student database. This reasoning is exactly what an exam question wants. First name? No. 2 students can share a first name, and in any class of 30, they very likely do. Surname? No. For the same reason, and more strongly. First, name and surname together? Still no. It is less likely, but 2 students called the same thing is entirely possible, and a primary key must be guaranteed unique, not merely usually unique. That distinction is the heart of it. Date of birth? No. In a large school, several students will share one. Email address? Better, it genuinely is unique, but it can change, and a primary key that changes causes problems everywhere it is referenced. Student ID? Yes, it is unique by construction, assigned by the school, never changes and never empty, and notice the pattern in those rejections. A good primary key is unique, unchanging, always present, and ideally short. Real-world data, such as a name or an email, fails at least one of those, which is why systems create an ID field rather than reusing something natural. Each field is given a data type, and the reasoning is the same as choosing a variable type in topic 8, text or alphanumeric for names, addresses, and codes. Numeric split into integer for whole numbers and real for values with decimals, such as a price, date, or time for dates, and Boolean for anything with exactly 2 states, yes or no, true or false, on loan or not on loan. That last one is worth being deliberate about. Whenever a field answers a yes or no question, choose Boolean rather than storing the text yes, because it uses less space and comparisons cannot go wrong on capitalization. And the trap is the same one from topic 8. A phone number, a postcode, and a product code are all text despite looking like numbers, because you never do arithmetic on them, and a leading 0 would be lost. Database fields carry validation rules, and this is the validation from topic 7 applied here. A range check on age, so it must be between sensible bounds. A presence check on surname, so the field cannot be left empty. A format check on a postcode or an email address, so it matches the expected pattern. A length check on a phone number, and a type check which the data type itself enforces. Declaring a field as numeric means text cannot be entered at all. That last point is worth noticing. Choosing the right data type is itself a validation measure, which is one more reason the choice matters. If a question asks what validation is suitable for a field, Name the specific check and say what it prevents. So, designing one from a description, the worked library example. You are told a library needs to store books and you must produce a design. Work through it in order. What is one record? One book. What do we need to know about each book? A reference, a title, an author, a year of publication, a price, and whether it is on loan. Those are your fields. Now a type for each. Bookref is text or alphanumeric because it contains letters. Title and author are text. Year published is an integer. Price is a real number. And on loan is Boolean because it answers a yes or no question. And the primary key is Bookref because it is unique to each book assigned by the library and does not change. Notice that the design answers 3 questions per field: its name, its type, and any validation, and that a question asking you to design a table expects a row for each field with those columns filled in. 4 things to take into the exam. First, a field is a column and a record is a row. Say which is which without hesitating. Second, define a primary key as a field that uniquely identifies each record, and when choosing one, reject the candidates with reasons. Names are not guaranteed unique. An email can change and a date of birth is shared. The reason is the mark, not the choice. Third, choose data types by what the data is and what you will do with it. Boolean for 2 state fields, and text for codes and phone numbers regardless of their appearance. And fourth, when designing a table, give the field name, the data type, and the validation for each, because that is the 3-column form the mark scheme uses.